Hey guys, it's Cassidy. So today we're going to be looking at a practice problem that includes all of the manipulations for K that we might see. So in order to do this problem, I'm actually going to write it out on my iPad so you can kind of see the process that goes through my head when I do this. So if you want to try this practice problem now, what you're going to be doing is given the following information, you're going to need to figure out what the value of K is for this reaction right there. Okay, so pause it here and take an attempt at it. And then if you're not really sure how to do it, you can unpause it in approximately 3 seconds and we will go over it together. Okay, so how do we do this problem and where do we start is probably one of the most questions that I get asked, right? Where do I start with this? So I like to start with kind of figuring out how can I get to my overall reaction? Because once I figure out the manipulations that these two equations need, then I can figure out how to manipulate my K values. So to do this, I'm just going to start with number 1 and see where I can get. So when I compare equation number 1 to this final equation that I need, I see that my N2 needs to be on the left side, but it's currently on the right side. So I'm just going to flip this first equation and see if that kind of looks a little better. So when I flip it, I now see that my NO is on the correct side. And I also see that I have an oxygen molecule now on the correct side. So I'm going to just kind of make a note that I reversed equation number 1. Now, equation number 2. So if I look at equation number 2, again, it looks like my O needs to be on the right side, but my N2O actually needs to kind of stay on that right side. So I don't want to flip it because if I flip it, then this N2O value is going to go on the left and it needs to be on the right. So I'm actually going to just write this equation down here and kind of get my mind in the right area first. So when I add equations up, I can put a line there and show that this is the final reaction. So let's kind of look at what we're dealing with right now using this highlighter. So I have one NO, and that's the only NO in this entire thing, and that's right there. So we are good to go with that. Now let's look at my N2s. I have an N2 here and an N2 here. Well, that's wonderful because they're on opposite sides, so they would cancel out, right? But the issue is that there's one more N2 on this side than there is up here. So I'm going to take that into account. Last thing that I can kind of look at, my N2s actually just completely will cancel out right now, but I don't want that either because I need an O2 in my final equation. Then if I even look at my N2O right here, it looks like I only need one of them, but I'm given 2. So obviously something still has to be done with that second equation. So if I kind of think through it, you got to use your critical thinking skills here. If I multiply this equation by 1/2, what I'm able to do is I'm able to get rid of the 2 there, right? So now my N2s cancel out. And then when I also do that, this becomes a 1/2 and this goes away as well. And now I'm good to go. So you kind of have to play around with some manipulations, and there's more than one way that you could do this problem, but that's kind of how I do it. So I'm going to say multiply by 1/2. Okay, so now I have my final equation ready to go. So up here with equation number 1, I reversed my equation. So my new K value, remember when I reversed the equation, I put it all over 1. So there we go. And when I do that, you should have gotten 2.44 times 10 to the 30th. With my second one, I multiplied by 1/2. So remember, when we multiply by 1/2 or multiply by anything, we raise the K value to whatever we multiplied it by. So 1/2. When you do that, you should get 1.55 times 10 to the -9th. Now, the very last step is that I'm adding equation 1 to equation 2 to get my overall reaction. So when I do that, I have to multiply my K values together. K1 times K2. So I would multiply my 2.44 times 10 to the 30th by 1.55 times 10 to the -9th. And I should get 3.78 times 10 to the 21. So this is actually a really, really good problem that kind of combines everything that we talked about, and it's putting it into one problem. This is definitely the most difficult it's going to get. Your professor can't really manipulate it more. So if you understand this fully, then you are good to go.